Have you ever stopped to think about how your phone just knows your face? Or how your watch tracks your runs so perfectly? That's all AI, working its magic. But here's the real question. How do we get all that incredible power without our batteries just giving up after 5 minutes? Well, that's the whole challenge of sustainable AI, and we're going to break it all down.
You know, it wasn't that long ago that AI was something that lived out there, somewhere, in these giant, mysterious data centers. But that's not the world we live in anymore. Today, AI is literally all around us. It's right here, in the devices we carry in our pockets and wear on our wrists every single day. And that brings us to the big problem. The very things that make our gadgets so amazing, how small and portable they are also their biggest weakness. They have really strict limits on power and processing. So we've got this huge mismatch, and we've got to figure it out.
Yeah, this slide pretty much says it all. You can think of it as two totally different worlds for AI. On one side, you've got cloud AI. That's the big, powerful stuff in data centers that's always hungry for power and needs the internet. But on the other side, you've got edge AI. That's the stuff that has to be incredibly efficient to run right on your device, sometimes with no internet at all.
So that really is the million-dollar question for everyone working in this field. How do you do it? It's this massive puzzle that's forcing us to completely rethink how we build and use AI. You can't just, shrink a giant brain and hope for the best. We need a much, much smarter approach.
So, what does that smarter approach actually look like? Well, the first part of the toolkit is all about making the AI models we already have way more efficient. Think of it like putting a super powerful AI on a really effective diet. The technical term for this is model compression.
And model compression is, it's pretty much what it sounds like. It's a whole bunch of clever tricks to shrink the size and the energy needs of an AI model. The goal is to make it lean enough to run on a small device, but, and this is the important part, without making it dumb. So let's look at 3 of the coolest ways they do this.
First up, we've got something called pruning. And honestly, this bonsai tree is the perfect way to think about it. Inside an AI's neural network, there are tons of connections, and not all of them are super important. Pruning is basically just snipping away the weaker, less essential connections. And just like with the bonsai, it actually makes the whole thing stronger and way more efficient. Next up is quantization. Now this sounds complicated, but you've actually done this a million times without realizing it. It's basically the same idea as saving a huge, high-resolution photo as a smaller JPEG file. You lose a teeny tiny bit of detail, so little you'd probably never notice, but the file becomes way smaller and so much faster to handle. It's the same idea, but for the numbers inside the AI's brain.
And this third technique, knowledge distillation, is just so clever. I love this one. The idea is you take a massive, super smart teacher AI, and you have it train a much smaller, more compact student AI. The little student model learns to copy the master, getting almost the same results, but with just a fraction of the brain power. It's brilliant, passing on the wisdom without the weight.
But hang on. What if, instead of going through all that work to shrink a big model, we just built a lean, mean, efficient one right from the start? Well, that's the next big idea in sustainable AI, designing these models to be efficient from their very DNA.
And researchers have been all over this. They've come up with whole families of AI models, architectures like MobileNets and EfficientNets that were born and bred for this. They're built from the ground up to squeeze every last drop of performance out of every watt of power. And then you have these wilder ideas like spiking neural networks that try to copy the incredible efficiency of the actual human brain.
Okay, now this is where things get really, really cool. We're actually using AI to design better AI. It's a process called hardware-aware neural architecture search. You basically just tell an AI system, hey, I need an AI that can run on this specific smartphone with this much battery and this much power. And then it goes to work testing out countless different designs automatically until it finds the absolute perfect, most efficient one for that exact device. It's incredible.
So we've got all these amazing, super smart techniques. But so what? Why does any of this actually matter to you and me? Well, the payoff for making AI lean and green is frankly huge. It impacts everything, from our daily lives to the health of the planet.
It all comes down to this number right here, 70%. That is the potential reduction in energy use we can get with these sustainable AI models. And get this, they do it while staying just as accurate as the big, power-hungry ones. Imagine your smart home devices running for months instead of weeks on a single charge. It's a total game changer.
And look, this chart just makes it crystal clear, doesn't it? If a normal AI uses 100 units of energy to do a task, a sustainable AI can do the exact same job using only 30. We're not talking about a tiny little improvement here. This is a massive leap forward in efficiency.
And that huge efficiency leap translates directly into real-world benefits you can actually feel. We're talking longer battery life on everything you own. We're talking better privacy, because if the AI runs on your device, your data doesn't have to go to the cloud. It means your apps feel faster and more responsive. And bigger picture, it means the entire tech industry can have a much smaller carbon footprint. So it all brings us back to this one big important question. Our world is getting smarter and smarter every day, filled with all this intelligent tech. The incredible work being done in sustainable AI is showing us a way forward. It's proving that we can make our technology smarter without making it hungrier. And the key is to keep asking ourselves that question. How do we innovate not just for more power, but for more efficiency and more responsibility?